Comes out of section 9.3, problems involving motion. So in this question, for those of you that took Physics 20, this is about a standard issue of Physics 20 questions you'll ever see. You're standing on a cliff 96 meters above the ground. You throw a ball upwards at 22 meters per second. Question is, how long will it take for the ball to hit the ground at the base of the cliff if gravity is negative 9.8 meters per second squared? You could put negative 9.81 meters per second squared, but the truth is we don't need our answer to that many decimal places anyway. This accuracy is plenty good enough. That's really the place where we start. We say acceleration equals negative 9.8. That's our acceleration function. It's a constant. If you know that to be dv by dt, you might realize right away that you could say, well, v equals negative 9.8 t plus some kind of a constant. But in this case, we can actually find the constant because when t equals 0, v equals 22, positive 22 meters per second. In this case, we're using kind of the usual definition that upward movement or velocity or displacement is positive and downward is negative. So that's why the acceleration is negative 9.8, but this is positive 22, so v equals negative 9.8 t plus 22. Now, remembering that that's ds by dt, we can actually find an s equals equation by taking the antiderivative of that again. So I'd have negative 9.8 t squared over 2, so negative 4.9 t squared plus 22t plus a constant again, but this time I'll call it c1 just because it isn't the same constant. So in this case, now that we have a position function, negative 4.9 t squared plus 22t plus c1, but we know that when t equals 0, we're actually at a position of 96 meters above the ground. So we actually know this constant as well. Negative 4.9 t squared plus 22t plus 96. This function is really where we were trying to get to, because now we can say, well, how long is it going to take for the ball to hit the ground? When does s equal 0? So we solve this little quadratic of negative 4.9 t squared plus 22t plus 96. So quadratic equation says negative b plus or minus square root b squared minus 4ac over 2a, and we crunch all these numbers to figure out what t equals, and so we get t equals negative 22 plus or minus the square root 22 squared minus 4 times negative 4.9 times 96 divided by 2 times negative 4.9. And you get two numbers out of that, negative 2.72 or so, or positive 7.21 approximately. One of these answers makes sense. One of them really doesn't. What does negative 2.72 mean? It just means if you had a parabola that described this motion, that if you went back in time down through the ground, you'd have another place where it hit 0, but it doesn't really relate to the real life situation. But this other answer does, and the answer is, that it takes about 7.2 seconds for this ball to hit the ground if you throw it up at 22 meters per second off a 96 meter cliff. Those of you that did take physics, you'll recognize, d equals vit plus 1/2 at squared, and some of these equations that you ran into in Physics 20. Really, they come from derivatives and antiderivatives. Now that you know a little calculus, take a look back at that formula sheet, and you might see some things that look kind of common to you or look kind of familiar to you. Anyway, the question here isn't who took Physics 20, it's who can take antiderivatives and find these constants, and there you go.